Hey guys, Tarek Merryface here. This episode of Mayday Talk is a little special. We're going to go back to one of my most viewed videos and discuss something that I didn't explain properly. In Mayday Talk episode 14, we watched a Queen Air spin and crash, killing more than 10 people, including all the occupants on board. In that episode of Mayday Talk, I correctly explained the mistakes the pilot made and what actions he should have taken. However, my explanation as to why the plane spun and crashed was inadequate and misleading, so here's an attempt to remedy that. Let's talk about why the aircraft spun and crashed. First off, basic principles of flight. How does a wing create lift? There are three basic principles involved in creating lift. The first one is Bernoulli's theory of fluid dynamics. At low speeds, air behaves just like a liquid, so we can apply physical laws about fluids to the air around us. Bernoulli's equation is not that complicated, but we don't need to actually understand it to answer this question. Just note that Bernoulli's principle states that when air flows around an airfoil, or a wing, the air going over the longest surface travels faster than the air traveling across a shorter surface. These two laminar flows over the wing's surface create a pressure difference that results in an upwards force. This is a textbook explanation of how an aircraft flies. Unfortunately, that's not the whole story, so let's move on to the two other principles that are required. The main way to create lift is by pushing air downwards. Let's expand on that. Air will collide with the incoming airfoil at an angle. This angle is known as the angle of attack. The air will then push against the airfoil and transfer some of its energy to it, applying a force on it. We separate the force experienced by the airfoil into its vertical and horizontal components. We call these components lift and drag. The larger the angle of attack, the bigger the lift, up to a certain point. After a point known as the critical angle of attack, the air can no longer flow along the upper surface of the airfoil and becomes turbulent. The force being applied to the airfoil becomes mostly drag. The airfoil no longer creates lift. It has now entered a stall. Now we can talk about how this affects a multi-engine aircraft. Unlike single-engine propeller aircraft, twin-engine propeller airplanes have extra lift that is created by the propeller wash over the wings as well as the relative airflow. So multi-engines are great when both engines are working, but a real problem arises when one of the engines fail. There are several reasons for this. The side with a failed engine will have less lift since there no longer is prop wash over it. At the same time, when the engine fails, not only does it stop providing thrust, but it also does something known as windmilling. This causes a huge amount of drag. Because the center of lift of each wing is at a given distance from the center of mass, this difference in lift will cause the airplane to roll and yaw towards the failed engine. This is known as asymmetric thrust. On top of that, the wing inside a turn or a yawing motion tends to generate less lift. Do you see where this is going? The wing with the failed engine has a lot less lift than the other wing. If left uncorrected, the wing with the failed engine can stall, whilst the other wing still has plenty of lift. This then results in a spin. At low altitudes, a spin is deadly, as we saw in the video presented in episode 14. We can of course do something to stop this from happening if the engine fails. Here's a generic emergency procedure after experiencing an engine failure on a multi-engine aircraft. Full power set, minimum blue line speed, check directional control and no longer sinking. Gear up selected, check flaps up. Identify and verify failed engine. Feather the propeller. Secure the engine. The first thing to do is to keep control of the aircraft. The extra drag on the failed engine causes the aircraft to yaw, which then causes it to turn. We can counter that by applying opposite rudder and a little bit of aileron, also in the opposite direction of the failed engine. The rudder pressure will have to be significant as you apply full power because of the increased asymmetric thrust. The pilot then has to have a minimum airspeed that is denoted as VYSE, or the single engine best rate of climb speed. This is more commonly known as the blue line speed, since it is denoted by a blue line on the airspeed indicator. It serves two purposes. The first is that it ensures that the aircraft will at the very least not descend and hopefully climb. This is vital in case the engine fails right after takeoff. It's also a good rule of thumb never to retract the landing gear whilst in a descent, so it also ensures that the pilot can safely retract the landing gear, which causes a lot of drag when extended. The reduced drag will also improve performance. The second reason is to give the aircraft a buffer between its current airspeed and what is known as VMCA, or the minimum control speed airborne. This is the minimum airspeed that an aircraft in the air can be controlled when one of its engines has failed. Below that airspeed, even full opposite rudder deflection will be insufficient to stop the aircraft from yawing and banking into the dead engine, eventually causing a spiral or a spin. Because of this, it is good practice not to turn into the dead engine when at airspeeds close to VMCA. As an aircraft turns, it experiences a G-force, and therefore the stall speed, VMCA, the blue line speed, all become temporarily raised. Therefore, if you're flying close to VMCA and start to turn into the dead engine, the aircraft is very likely to go below VMCA very quickly, which will result in a spin. This, unfortunately, is what happened to the Queen Air in the video. And that's the aerodynamic behind the crash in the video. Ultimately, it all comes down to poor airmanship. It was a tragedy we would all like to never see again. If anything, this video is a reminder to regularly practice your single engine failure procedures. It also reminds us that pilots and mechanics alike can get complacent. You can find out more details about the crash by watching Mayday Talk episode 14. But that's it for this video. I'm Tarek Merryface. I'll see you guys next time, and happy flying. Hey guys, Tarek Merryface, thanks again for watching. Please comment, share, subscribe if you enjoyed it. And I personally have been wanting to make this video for a long time. Mayday Talk episode 14 is the most viewed video on my channel, and it's kind of embarrassing because I gave a terrible explanation for the aerodynamics behind that crash. And so I've been wanting to make this video for a really long time to rectify that mistake. So, if you are a pilot, a flight instructor, or someone along those lines, and you find a mistake on this video, please tell me. I do want to correct it. I've been wanting to get this video right really badly. Anyways, I'm Tarek Merryface. I'll see you guys next time, and happy flying.